Hi everyone, good morning, good afternoon, good evening. My name is Ayush Rungta, and with me in my team I have Subhashri and Sudhakar. We all are working professionals, and our team name is SARATHI. As per Hindu mythology, SARATHI name was given to the Krishna, who was the path pavers, the guiders to everyone out there. And that's what we want our service to be for ONDC clients and customers, and give them the most beautiful experience in the retail journey. So before we jump into the problem and start thinking of the solution, let's ask the most basic question. What does ONDC want? What does our end customer wants? The answer is very simple. Savings. Savings could be in time of money, could be in time of resource, could be in time of the time spent. So it could be any type. So what we want is to optimize everything and make it super cheap. So for that, we have identified the four areas on where we want to our system to work on. One would be to have cheap alternative and maybe use something like OpenStreetMap, which is open source, so that we don't rely on Google Maps and Google Maps traffic to get the most optimized route. And since Google is a paid per use service, so this is where the majority of cost will go. So we want a solution there, and then we want a scalable system. So our system should be able to handle a small number of requests, let's say 5 requests per second to maybe thousands or lakhs of requests per second. And it should also be scalable intercity to intracity to intra-country and inter-country. That's what our goal is. And we also want an optimized system. Optimization will have two degrees here. One would be route optimization on the most optimized route which the driver would take, and delivery network optimization, like where to pick, which order to pick, how many orders can he pick in his one ride, and how many orders he can deliver. So that's also part of optimization, and all this should be accurate. I mean, there are a lot of meaning parts here, moving parts here. Moving parts would be the users, the increasing demand, the decreasing demand, the live traffic data changing, the restaurant preparation time, reservation live time. So a lot of moving parts, so we want everything to be accurate, since real items in retail are there involved. So for that, let's jump into the architecture of how we have planned this. So to address the first question on how to leverage open source maps. So before I tell you about our solution, it's very important to know open source map. How does that work? So every map has a zoom level. So that zoom level ranges from 0 and it can range till 15. So 0 would be the base where that would include data like the topo data of the city or the grid. That could be like what are the structural areas, do they have mountains, rivers, and the last zoom level would be zoom 15, which will have like POI's area and all the in-depth details of the map. And in the middle of a spectrum, you will have multiple kinds of data, which could be anything. Could be the street name, the area name, the clusters, the local park name, or anything in general. So what we have done is we have leveraged OpenStreetMap यहाँ पे to get the data of level 0 to 40, which won't be changing very frequently. It's very unnatural for topographical area to change overnight. So for different zoom levels, we'll have different refresh rate, which will be handled by our Flink. So Flink will handle all the jobs of updating all the PY types and all the different zoom levels. So once that is established in this sector, now the most important questions comes: how do we get the real traffic data? Even though OpenStreetMap has an endpoint where we can get traffic data, but it's not very precise, since it's based on user telling like user voluntarily giving data, so it's not very accurate, and we don't want to compensate on accuracy here. So we have thought of a way where we can use Google Maps and can still be very, very cheap. So I'll explain that. In the zoom 14 level, I'll just make a small grid. Let's say our map is of Bangalore, so this is what Bangalore looks like. So we divide the whole Bangalore ka map into multiple grids. So this grid could be 1x 1 kilometer, 5x 5 kilometer, 10 cross 10. It's very much configurable. So once we make the grid, So what we do is we make a call to Google Maps traffic API and get the traffic of all the Bangalore in one call. Once we have the traffic data, we add that layer of data from Google Maps in the top of our OSM data. Once we have a ready-made data, we store it in cache. We need not to make every new call which originates from Bangalore to Google Maps, but now all these calls will land to our own map service. So we'll be the map service provider replacing Google. And this refreshing of data will be handled by Flink, and this could be every 30 seconds, every minute, or every 2 minutes. And this is only for Bangalore. We can also request the whole traffic data of India and then segregate and have a load balancer there as well. So this system can be scalable, and every 30 seconds or every minute or every 2 minutes, depending on the kind of accuracy we want and the kind of accuracy the retailer wants, we can configure it. So from now on, all the discussions, if I use the term map, that will be our map service, not the Google Map service. So our map service would be actually pretty much accurate on what Google Map provides. So now that we have solved the first problem of minimizing the cost, let's talk about the customer journey and how to optimize everything. So customer could be anyone. I mean, we are customers. If I open a ONDC app to order a food from McDonald's, let's say burger, I am a customer. So from the customer side, I'll onboard in the app. As soon as I open the app, I have a layer of API gateway, which is used for authentication and do all the firewall process and everything, so that the customer is secure in our platform, because security is also a huge concern for us. Yeah. So once the customer is inside the app, we take the customer's current location, and we need to get the list of all the POIs. So let's say the business is based on food and beverage. It could be also medical. It could be also manufacturing business. It could be a waste management system. These will have different PO types. But for our discussion, let's assume we are into F&Bs. So the customer goes in, let's say he was searching for all the POIs. POIs is nothing but point of interest. It could be a McDonald's or a Wendy's or a Domino's. So the initially we take the customer's location, and then we pass the geo hashed value. So this geo hashed value could be anything. I mean, it could be geo coordinates, it could be Uber cell, it could be geo cell, anything. We have an API internal SDK server to auto convert the different configurations. So as soon as he makes an API call to get the list of POIs, we go to our own map service. We get the POIs for a specific range. Let's say our deliverable range is only 5 kilometers or 6 kilometers, 10 kilometers. We get the list of all the POIs to serve. And this POI has a certain feature to it. So we have a POID and a geo hash for each POIDs, which will be auto-linked. We'll talk about why this geo hash value is very important in the later stage. So as soon as the customer gets list of all POIs, then let's say he chooses, like he gets Domino's, Burger King, and McDonald's. He chooses McDonald's, he goes to the menu, sees a veg burger he liked, and he places an order. So as soon as we receive a request to place an order for a burger at McDonald's. So this flow gets activated where he posts the order and the POI ID. In this case, POI ID would be McDonald's. The user has an order and a PO ID. So in this case, the PO ID is McDonald's ka some ID. So that is received by order service. So now order service is responsible for handling all the orders and maintaining the whole life cycle of the order. So order service will make a get request call to delivery partner service, which is our own service, wherein we pass the geo hashed value of origin, destination, live location, and everything along with the pickup time. Like what is the estimated pickup time? Restaurant could take 5 minutes to prepare burger, but 20 minutes to prepare biryani. So that is also configurable here. So delivery partner service main task is to choose a delivery partner for our ride. So for that, since we discussed, we have an open source map which has grid system. So orchestrator would be responsible to choose which driver from which grid. So this will have multiple reasons. Let's say there's an already rider going to a same POI type. Let's say McDonald's may some other driver is already going. So we'll pick him pehle if his drop location is same as the stop location. If not, we have a fallback mechanism where we see if some other driver is driving along the route, and maybe from a certain delta detour he can pick up the order and also drop the order. If not, we assign a new driver. So this all is handled by our orchestrator, and the delivery partner service gets as a output one of the delivery partner. Then we make a get request to calculate the route, which will also calculate distance matrix, calculate the most optimized route. So this will include the lat long of driver, the pickup location, everything. And that route calculation uses Valhalla, which is an open source map SDK platform, which can calculate the most optimized route for multiple pickup points, multiple drop points, and give us an output. So once we have that, this data goes into order service, where we also store this data in cache. So benefit of using cache is we have the geo hashed value. So now the importance of geo hash value comes into picture. Let's say there is a building, a society of 400 people. They will all have more or less same geo hashed value. Now if all the users, like let's say it's lunchtime around 2:30, everyone wants to order something, they all open their app. So usually what will happen is your server will get overloaded. But since we have the geo hash value, no need to make a new request to our backend. We can just leverage that geo hash value and serve all the customers from our cache. So our backend would be not overloaded, and it will be like very nice for our system throughput. So once we have that, we keep the order ka life cycle and maintain it until the delivery is there. So now let's go back to the rider side. So rider will always be pinging his location to our WebSocket, which will authenticate the driver if it's a legit driver in the fleet or not. Then the orchestrator would be assigning a region. This region will be keep changing. Let's say I am in Marathi, which is a region, but I move to region 2. Orchestrator will also act as a zookeeper and change the values. And then driver would also be sending events to the WebSocket, and this event could include change in route or route deviation from the original route, and the final event would be when the order is delivered. So the geofencing API we have to check if route is overlapping or if route is destination or something. So then we have an event, and if we validate the event and if the order is successfully delivered, then we maintain the life cycle of order service and we conclude that the order was delivered. And then the user orchestrator can again put the driver back in the system, and that's how the whole ecosystem will work. So let's talk about the advantage of this. So advantage is we are not making calls to Google API. We have our own Google Maps, a clone of Google Maps in our local system. So we save around 92% in the API cost here. And also the system is pretty much scalable. It could work for few requests per second. We can have multiple instances running to multiple like thousands or lakhs or millions of users. And we can also scale it from Bangalore to Chennai, Bangalore, Chennai, Ahmedabad, Bangalore, Chennai, Kolkata, to networks inside the country and outside the country. And it's very plug and play system. Let's say you want to configure something, you want to add something new, you want to add a search pricing. Need not to change the whole logic, just have a new service spin up and add it in the layer, and you are good to go. And also, if at all ONDC wants to send this to share this to other retailers, so it can act as a IaaS, like you can set it as a service, the whole infrastructure. And this is optimized for maximizing the profitability and efficiency of drivers and retailers, so that you get the order quickest and and the driver gets the most efficient way, like maximize pay for minimum effort of work. Yeah, thank you.